Alright, last thing we need to talk about in Chapter 9 is percent yield. And we've actually already done a little bit of this in lab, but I have not actually given you notes on it. Now, percent yield tells us how good our measurements are. It's kind of like getting a grade in class. The closer to 100, the better you are. Except in percent yield, you can't go over 100%, because that's bad. We'll talk about a little bit why that's so later. Now, percent yield, we have a nice formula that we use. Percent yield is equal to our actual yield. Our actual yield comes from what we actually measure in lab, divided by our theoretical yield, which is what we calculate on paper, times 100. Really nice formula. Kind of helps us all bring it together. How good was your lab experiment? Now, let's try a practice problem with percent yield. When 45.8 grams of potassium carbonate reacted with excess hydrochloric acid, 46.3 grams of potassium chloride are formed. Calculate the theoretical and percent yields of potassium chloride. Right? Like with every stoichiometry problem, we have to start off with a balanced chemical equation, which was nicely given to you down here. Now, second thing we need to do is we need to identify our knowns and our unknowns. Right? It says to calculate the theoretical and percent yields of potassium chloride. Well, those are our two unknowns. That's what we're trying to find. So, before we can calculate percent yield, of course, as we have to have that theoretical yield, we must first calculate the theoretical yield. So that's our primary unknown, the theoretical yield of potassium chloride. Our knowns, we have two knowns. The first known is we know that we're starting off with 45.8 grams of potassium carbonate. We're going to have more than enough HCl, so we don't have to worry about HCl in this problem. This is not a limiting reactants problem. And we know also that 46.3 grams of potassium chloride are actually formed. So someone went into the lab and performed this lab experiment for you. And they gave you this data. Now, we have to determine the theoretical yield so we can determine our percent yield overall. So let's start off with our theoretical yield. It's a stoichiometry problem. We've got a balanced chemical equation. We've identified our known and unknown. The third step, of course, to all stoichiometry problems is to set up our conversions. We always start with what we know. We know that we have 45.8 grams potassium carbonate. So then we start working with our conversions. We're trying to solve for grams of potassium chloride. But we know, as with all stoichiometry problems, we must first go from our starting units, whether it be grams or liters, to the mole. We go from grams to the mole by using the molar mass from the periodic table. So the molar mass of potassium carbonate is 138.21 grams per mole. Grams of potassium carbonate, of course, cancel. Now we have to go from moles of potassium carbonate to moles of potassium chloride. So moles of our known to moles of our unknown. We do that by using the mole ratio, which we get from the balanced chemical equation. And we know that there are two potassium chloride, 2 moles of potassium chloride made for every 1 mole of potassium carbonate used. So we can put that in there, 2 moles of KCl per 1 mole of potassium carbonate. Potassium carbonate cancels. We're left with moles of potassium chloride. And we have to go to grams of potassium chloride. We know that we go from grams to moles or moles to grams using the molar mass, which we get off of the periodic table. Moles must, of course, go on bottom, so they will cancel. Multiply all of our top boxes, divide by all of our bottom boxes, and we get 49.4 grams of potassium chloride as our theoretical yield. This is our theoretical yield. So, simple enough now. We just plug in our numbers to our formula. Our actual divided by our theoretical times 100. When we do that, we should end up with 93.7%. So this is our actual amount. This was given to us in the formula. Divided by our theoretical amount, which we calculated using stoichiometry, times 100 gives us 93.7%. And that is Chapter 9.